Hi everyone, welcome back. Today we are solving balance a binary search tree. So the problem is pretty straightforward. We'll be given a tree and we want to make it balanced, and a binary search tree is balanced if the depth of two subtrees of every node will never differ by more than one. And if there's more than one way to make it balanced, we can return them in any of the ways. So if we look at this example, we can return it as this tree or we can return it as this tree. In this example, we can just return the original tree because it's already balanced. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, it would be pretty straightforward, but it's probably more easily said than done, because how we'll solve it is that we will just first traverse through the tree using in-order traversal, and then we will use the traversal to add the nodes into a list. And then after that, we will build a balanced tree using that list that we made. And to make it balanced, we will just always choose the middle node, so we can split the left as the left side of the middle node and the right child to the right side of the middle node that we choose from the list. And we will continue that until there are no more nodes to add to the tree, and then we will return the balanced tree. So let's go through this example real quick. First, we add the nodes into a list using in-order traversal. Then we will choose the middle, which is 2. Left will be 1, right will be 3, 4. Look at the left. The middle is 1. It doesn't have a left or right node, so now we'll look at the right node of this tree, which would be 3 and 4, and we'll set the middle to 3. Right side is 4. It doesn't have a left, so we'll just add the right side. And now that there are no more nodes to add, we can return this tree as our result. So the time complexity would be O of n, where n is the number of nodes in the tree, because that is the number of nodes we will traverse through. And the space complexity will also be O of n, because we will be using recursion for the in-order traversal and also to build the tree. And the recursion stack can take up to n space. And also this list right here can take up to n space as well. So now let's get to the coding part. So first we will set up the in-order function. So we will have node and the list vals. If there's no node, we just return none. Otherwise, we will do the in-order traversal. So it will be left. Then we will take the value, node.val. And after that, we will do in order of node.right. Okay. And now we will do the function where we build the tree. So we will need the list vals and left and right. Now, if left is greater than right, that means there's no more node. So we will return none. Otherwise, we will set the middle to left plus right divided by 2 and floor division by 2 to be exact. And node would be the tree node of vals of mid. And the left will be the build function of the vals list. And left will stay the same, but the right side will be mid minus 1. And for node.right, we will also use the build function. Keep the vals list, and the left will now be mid plus 1 and the right will still be right. And finally we'll return the node. So now we'll initialize the list and use the in order function, and we will return what we have from the build function. Okay, let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.